Okay, we are live. Hello and welcome, dear FRENS Validator community. Such a cool day because today is actually the last interview for this year. It has been a crazy year with a lot of crazy things that were going on. And we are wrapping the year up with Christopher Goes from Namada, and he also works on Anoma and has like a long history in the interchain behind it. During waiting for more people to join, hello, Chris. How are you doing? Good morning to Oregon.
Good morning, and thank you for having me. Good evening to Germany. I'm doing pretty well. For us, it's like the last set of engineering sprints of the year. So we actually launched the Namada public testnet today. You can find out more. There's a Namada testnets repo. I can post a link after the show or something in case you're interested, but it's open to anyone to join.
Yeah, 100%. And we will also dive deeper into the testnet just in a minute. But before we do that, so I mentioned it. You are a long time cosmonaut. So for people to get like a context of everything, could you like briefly share your journey in the cosmos? So we have like kind of a context here.
Yeah, so I started working on the Cosmos project not as early as some people, but certainly before it became super popular, before the launch of the Cosmos Hub. I started working on Cosmos about a year before the launch of the hub. I was recruited by Jim and by Adrian and Ethan Buckman at the time. And I was particularly interested in working on IBC just because the idea of a interoperability protocol between different economic communities or sort of autonomous zones who wanted to use decentralized ledger technology to settle some of their commerce, but also wanted to interoperate with other zones while retaining autonomy. That sounded to me like a kind of requisite constituent component. At the time, I also read a bunch about polycentric law and some other concepts, and it seemed to sort of map onto this topology well. So I was interested in working on IBC specifically, and I accepted the deal that I would help with the launch of the Cosmos Hub, which was supposed to take 3 months. And in return, I would get to work on IBC, and it didn't really take 3 months. It took like 12 months. There's an entertaining blog post. I think it's by Tendermint, or the former All in Bits company. Still, I don't know what it's called, but Tendermint, All in Bits, DBA Tendermint, whatever, that company, that goes through the history of kind of various, All in Bits diaspora organizations that formed from people who left that company at various times. But it also talks about the predictions of the launch time of the Cosmos Hub. And I think at the time, I predicted that the launch of the Cosmos Hub would take a year and something like, I predicted February, and it was off by 2 weeks a year before. So there was now, of course, I've completely lost my ability to make predictions because I'm like planning a project. And so all my predictions are wildly optimistic. But back in the days when I did engineering, at least at that point in time, they were accurate. Anyway, after the launch of the hub and after a week of getting some sleep, we started working on IBC. And I worked on that for the next year and some change, initially with All in Bits and then with Interchain GmbH, when the engineering team decided that we also needed to be autonomous and fitting with the Cosmos vision. And I stayed with Interchain GmbH until IBC launched and just thereafter. And then now, about almost 2 years ago, left to work on Anoma and later Namada. So yeah, lots of terms and names, but sort of a running trend of permissionless protocols, interoperability, and trying to contribute where I can to the Cosmos.
Yeah, I mean, sounds like a wild history that you've had in the interchain. And yeah, you mentioned it. Now you're working on Anoma and Namada. So I think it's very important for this discussion to to find the distinction here. So let us start a little bit by talking about Anoma. So what is Anoma from a very, very, very high level? So for people who have never heard about Anoma, what is the first things that they should keep in mind? Maybe also for people who are like completely new to crypto and to Cosmos.
Right. So I guess the highest level way to describe Anoma that I think is helpful is to talk about two parts, which are counterparty discovery and settlement. So most people who have used blockchains before are pretty familiar with settlement, because settlement is what you do when you send a transaction to a blockchain. You want to send someone some money, you want to trade with your friend, you've decided on what to do, and you want to order that transaction so you can agree that it happened and agree that the results were X, and no one can double spend. And blockchains solve that problem. They solve the problem of ordered settlement and preventing double spending. So settlement is great. But in general, it's not sufficient, as in we find with most kinds of decentralized applications that people want to, before they settle, first discover who it is that they are going to interact with. So, in the case of just sending funds to someone, you don't need this because there's only one party. But whenever there's more than one party, you have to find that party somehow. So if we think about something like OpenSea or like DYDX or some kind of exchange, you're usually finding your counterparty by querying some orders that are stored in a database. Or in the case of a AMM like Osmosis or Uniswap, your counterparty is sort of mediated directly by the smart contract on the blockchain. So you're using the chain to store counterparty information, somewhat indirectly, but basically that. If we think of other kinds of like 0x, other like Ethereum exchange protocols, they tend to feature off-chain databases. So somewhere there's a server that stores a database of signed messages, orders. They can take different formats, and those signed messages are queried by users to find potential counterparties. And the reason counterparty discovery is so valuable is that one of the advantages of these kinds of programmatic systems is that in many cases, when you're using them as a user, you don't care about who your counterparty is. You just care about what it is that they can provide to you. So I want someone who will, swap my A for B, or someone who will take my CryptoKitty and give me some different NFT token, or for in the land where NFTs represent real things, I want to swap 1 week at my house for 1 week at your house. But I don't really care, which you it is, as long as you're like located in Lisbon, right? So often the criteria for which counterparties you want to discover can themselves be expressed programmatically. And Anoma tries to, in addition to solving the problem of settlement, which is the problem that blockchains traditionally solve, it also tries to solve the problem of counterparty discovery in a sort of unified architectural way, and provide to application developers, instead of just providing the interface of settlement, which is what they currently have, where all applications like Uniswap or Wyvern or OpenSea or 0x have to build their own counterparty discovery infrastructure. We build a generalized counterparty discovery infrastructure, so developers can use that. And if you look at many of these contemporary decentralized applications, most of the complexity is in the counterparty discovery part. The settlement part, aside from being, they spend a lot of time on Solidity or EVM gas optimizations, but the settlement part is not that complicated. In part because it's just conceptually simpler. Once you know who your counterparty is and what you want to settle, you've decided on the state transition. It's pretty easy. It's easy to make that private. It's easy to do lots of things. But counterparty discovery is more complicated because you're dealing with these partial state transitions, which have to be composed together. And you might even have multiple options of composing them together, and you need ways to select that, stuff like this. So Anoma kind of adopts this slightly different view of what interface it is that these decentralized systems should be providing to application developers, and tries to build a stack to fulfill that interface, and also provide sort of privacy and other kinds of features that developers might want. So Anoma is like you could say a long-term architectural project. Namada, by contrast, is a immediate solution to the problem of we need privacy now, or we need sort of practical privacy now. At least at the moment, the primary options for privacy in the blockchain ecosystem are either a sort of separate, generally not interoperable chain that reissues assets like Zcash, where Zcash has fantastic world-class privacy, but at least at the moment, in order to use the privacy of Zcash, you must use the asset sec. And nothing against the asset sec, but just many users, I think, have other preferences for what assets they want to use. Maybe they want to use stablecoin. Maybe they want to use, Zec has like Bitcoin's monetary policy, and Bitcoin's monetary policy is an interesting experiment, but it's just not clear that it makes sense for example, means of payment, which is one of the use cases where privacy is really important. So one option people have is a chain like Zcash, where they have to use the native asset, and the other option is usually some kind of Ethereum contract or sidechain, like, well, at least formerly Tornado Cash, depending on whether you're a U.S. citizen now, I suppose, or Aztec. And these solutions sometimes have usually slightly weaker privacy, although it's close, but just tend to be not very user-friendly. It takes too long, it's too expensive, you have to wait, settlement delays on Ethereum. It's not the brilliant cryptographers working on these things, but they're just hampered by dealing with having to settle to the EVM, and their architectural choices are constrained by that. So Namada is an attempt to bring this world-class privacy technology, which by and large already exists, sort of upgraded a little bit so it works for multiple assets, and fuse it into a product proposition that makes a lot of economic sense. So to give users cheap transactions, we have a reward system built in so that users who keep their assets in the shielded pool can earn rewards because they're providing privacy, which is a public good to other users. We have kind of a modern proof of stake system, all of this stuff, just all in the attempt at providing one very simple function, private transfers and sort of decentralized private asset custody on Namada, while retaining interoperability with the rest of the Cosmos and Ethereum ecosystems.
Yeah, and we will also dive deeper into some things that you just mentioned. For example, what kind of developers will start building on Anoma or with Anoma, or also on Namada, of course. But before we do that, so let's bring this into a broader picture. So you're basically leveraging the infrastructure of Anoma to have a more direct approach to solve the privacy problem, and this is just possible because you're leveraging Anoma, right?
That's part of it. Namada uses Tendermint, the Tendermint Go implementation, developed by Informal and IG and all of it. There's everything else is custom, but we use a stock Tendermint 0.37 line at the moment, with a state machine written in Rust and sort of circuits developed. We built on some circuits originally developed by the Electric Coin Company and extended them for multi-asset functionality and conversion functionality. So some of this is, Namada doesn't use the full Anoma stack. Parts of the Anoma stack, like Typhon, which is the consensus engine that we're building, are not complete yet. And, in general, we try and, it's a bit dangerous to deploy cryptography that you just invented. We prefer to sort of develop the cryptography, let it sit for a little while, socialize it to some people, let them take a look at it. So Namada is using cryptography that we developed, maybe 6 to 9 months ago, which isn't that long, but it's longer than 0. And if we launched with Anoma's full cryptography stack now, that would be 0, and that's a little bit too scary. There's some intentional phased technology deployment going on. So I would say the Namada leverages in part the Cosmos software stack, and part it leverages some of our cryptographic research of other projects which came before. And in particular, it just leverages the appealing proposition of kind of cheap interoperability. So we don't expect users to issue assets on Namada. We, by and large, expect them to bring their assets from somewhere else. So to bring their assets from Ethereum, to bring their assets from other Cosmos chains, to bring their assets from other chains which are connected to those chains over IBC and over the Namada Ethereum bridge, just to use the privacy features. And they can stay on Namada as long as they like. It's cheap, it's fast, it's private, and then they can go back to their chains whenever they want. So we're trying to provide that specific feature with Namada.
We will also talk about the bridge in a second, 100%, because that's a very interesting take also on how to use or why to use Namada. But yeah, last question in regards of Anoma. So could we talk a little bit also about the broader architecture? So there are some features that Anoma provides that are special, for example, the black box. So could we talk about this privacy feature?
Right. So one of the reasons that Anoma takes a long time to develop is that we're trying to unify the developer semantics of private and non-private applications. And the reason that we want to do this is that in the end, the thing which is really scarce is developer time. And if you have at the moment, there are basically completely separate systems for developing private and non-private applications. So there's the sort of ZEXI programmable private state transition circuit line of research, which in part we build on. And then there's the sort of Ethereum VM or COSM sort of transparent virtual machine line of research and architectural development, which we also take some inspiration from, but these two have been totally separate. And they've been totally separate, I guess, for reasons that at least I think, are primarily historically contingent, not fundamental, as in there have been transparent VM designs around for a long time. The EVM took its inspiration from how operating system sort of process multiplexing, application multiplexing works, whereas sexy and other sort of privacy oriented application architectures have constraints imposed by using zero-knowledge proofs. So they need to segment their state, they need to split their state transitions. But these are also the constraints imposed by kind of treating your applications like parallel circuits or something like this. Like they're not, it has more to do with the data model than it does with privacy. So the disadvantage of having two completely separate application architectures is the developers have to choose. So in principle, whether an application is modular developer time, whether an application is feasible to make private or not, depends on kind of its state architecture, and it depends on how complex the application is, and will the, prover, probably usually the constraint is prover time, will the prover time for that application be too high to sort of as to render it unusable, or will it be low enough that it's okay for users? Like users using their phones want proof times that are a few seconds, and if it's more than that, it just won't work. So there's some pretty like hard constraints in this feasible application design space. So at the moment, even though those prover costs tend to come down over time, right? That's more of a function of the underlying research into zero-knowledge proof systems, which is making rapid progress. Still, developers have to choose, do they write their applications in this transparent way, for this transparent architecture, in which case they are never going to be private, or do they write these applications for this private architecture, in which case they're kind of, if the provers are fast enough now, then maybe it works. But if they're not, then it doesn't, and they can't easily, they have to write a completely separate application for the transparent world, right? So this seems, at least to us, seems unnecessary. And if you unify these architectures, then developers can write basically one application, and whether or not it is private or whether specific interactions are private is chosen at runtime by the users. It's not chosen by the developers. The developers still have to do a few things to make sure it's compatible with this sort of a compilation stacked circuits that we're building, other stuff. But by and large, that decision of privacy is one made at the sort of runtime configuration instead of at the development time. And the great advantage that this gives to developers is that developers can build their applications now, use them transparently, at least in large part where it's fast, start making parts private as the zero-knowledge proof systems get faster and faster, and then over time, their applications just become more private, quote unquote, for free, because they built them on top of this architecture, which is already compatible with, zero-knowledge proof-based or even homomorphic encryption-based private state transition systems. And so as the underlying proof systems get faster, they just download the latest version of the compiler, and then they compile it again, and then now they have more privacy or more, faster proof times for their private application interactions. So for that reason, we're, trying to unify these architectural semantics. And that's part of the, what we consider this black box, as in developers using the Anoma architecture should be able to write their applications in this way that is kind of abstract from the underlying details of, what proof system is being used, what even in many cases, whether the particular state transition is private or not. And those choices are made more by the compiler stack and by users later at runtime.
I see. And to wrap the Anoma part a little bit up, and to continue with Namada, last maybe if you can, it would be super cool if you could share some updates. So where are we in a developmental stage right now? So when mainnet, when token, of course, the most asked question in the crypto industry, and maybe if you can put it down in 1 or 2 sentences, where will Anoma be in 2 or 3 years from now? What's the final vision?
Sure. Where are we at right now? Anoma at the moment consists of a bunch of what I would call prototype quality code along with specifications. So we have prototypes for Taiga, which is the private state transition component. We have several prototypes for Typhon, which is the peer-to-peer consensus and execution component. We have several parts of our compiler stack, including Juvix, Geb, and Vampire, in sort of prototype E stages where they are definitely capable of being experimented with, but we would not yet encourage anyone to use them in production. I'm hoping that we can, many of these things are starting to be sort of fully integrated, although we've built them in parallel. And I'm hoping that we can unify them and sort of have things that are ready-ish near the end of 2023. I mean, we're not, we're really trying to get the interfaces right, so that developers have a stable and correct set of abstractions on top of which to build. And getting that right is it's maybe more, we care about like the time to Anoma being useful, not the time to Anoma blockchain launch. Those things are related, but they're not completely the same. But I'm hoping that late 2023 will be possible.
Nice. Yeah, 2023 will be like an exciting year. So many big launches are around the corner. So yeah, this will be like a very, very exciting year. Can't wait for that. But yeah, let's move on and dive deeper into Namada. So you mentioned a little bit, Namada is, let's say, the straightforward solution in order to focus on privacy right now. And I want to start this conversation with like a more philosophical one, because in crypto, people always talk about the blockchain trilemma, like decentralization, security, and scalability. And this hinders us from mass adoption, so to say, because you may be a decentralized and secure chain, but then you lack in terms of scalability. But a lot of people claim that you are like really ignoring one aspect here, which is also privacy, because I mean, you can have the super securest, decentralized, and most scalable blockchain in the space. If your boss is able to see on what kind of products you spend your money on during the weekend, a lot of people won't feel that comfortable with that. So would you argue that it's actually like a blockchain square lemma if we really talk about mass adoption, the broader masses care about?
Oh boy. Maybe. I mean, luckily, at least, privacy is not in competition with these other dimensions. It actually makes scalability easier, at least when done correctly. I would say privacy is a prerequisite for like broadly deployed social coordination systems, including but not limited to blockchains. Unfortunately, we've ended up in this weird world equilibrium where there's a lot of surveillance going on, and it's terrible. But it's also very new. I mean, before the past few decades, during which there's been a kind of, slightly propagandized shift in mainstream consensus opinion. The government or large corporations just did not have that much data on individual people. Of course, if law enforcement wanted to prosecute people, they could do that, but it required like dragnet surveillance just didn't exist, right? It required sending agents conducting investigations. It required human time. So there was this balance between the cost of surveillance, such that it was not just trivially easy to capture everyone's data and selectively censor, selectively target people. And we've unfortunately moved into a world where it's very easy to do that. And governments and other parties with sort of asymmetric levels of control over these information systems have found that bait too tempting, as expected, and the only plausible way to shift this equilibrium back to one which is reasonable is to change the sort of a technical architecture of these systems such that data is just not available to any particular central party to dragnet surveil like this. So that's not to say that like sometimes I think people conceive of this as a kind of dichotomy between private systems and transparent systems, where like in private systems, everything's private, and in transparent systems, everything's transparent. And privacy doesn't work like that. Privacy just needs choice. So in a private system, you have choice as a user of which data you disclose to who. And a transparent system means that that data gets disclosed regardless of whether you wanted it to or not. So all systems are kind of like even private systems allow you to prove things to people. And say Zcash or the cryptography that we build on top of Namada as well allows you to prove anything you want about your interactions to anyone you want. It's just consensual instead of by default to everyone. So yeah, I mean, also I would say please be careful using transparent blockchains when you put your transactions on an immutable ledger that is copied in many places and is never ever going to be deleted, anyone in the future who would like to, find something you did that is now, or at that time, unfavorable or cancel worthy or whatever, they can search the ledger. So yeah, be careful what you wish for. I think we saw this early on with ENS names, where a bunch of people registered like personal ENS names and then started being absolutely terribly afraid, after a year to actually use their accounts on Ethereum anymore, because it would be public to their employer, public to their friends, public to their enemies, public to the, unknown future of overbearing capital or governmental overlords. And that is, a sad reality. So the sooner we switch to private systems, in other words, the better.
Yeah, but I really remember this one time also, because it was also, to be fair, of course, it was for the sake of mass adoption to have like a nicer address, but there was also kind of a flex behind it. Who has like the cooler and the more shorter address, and what kinds of CryptoPunks can you see on this address? So it was actually also kind of a flex, I would argue. But yeah, I totally agree with that. But on that note, you started this conversation a little bit early already about the bridge, and we will talk about the bridge in a second, but you also talked a little bit about what kinds of things users will do on Namada. So what kinds of products and protocols can we expect on Namada, and why should I, as an end user, use Namada?
Right. So the primary proposition we're trying to sort of provide to users with Namada is privacy by default, while retaining the ability to do everything else that you want to do. So Namada doesn't support a lot of features. It just supports private transfers and sort of private decentralized custody, as in storing your assets on the Namada chain. It has, the background infrastructure like proof of stake and bridges and IBC integrations to enable all of that, to make it work smoothly, quickly, cheaply. But the primary, if you want to do other things, like if you want to trade your assets, if you want to interact with different contracts, if you want to, go, rent a server on Akash or something like this, those interactions will all happen outside Namada. So we're building something that we call shielded actions. And shielded actions makes use of IBC to allow users to keep their assets most of the time on Namada, benefiting from the privacy of the shielded set and earning some shielded set rewards, while whenever they want to take some action, send their assets over IBC in a packet that contains some instructions about what to do. So as a user, you will be able to go to the Namada interface, select like, I want to, say, swap on osmosis. And then your assets will be sort of unshielded quickly on Namada, sent in an IBC packet over to osmosis, swapped on osmosis, and shielded back on Namada. And in order to do this, you don't really need to leave one interface. So all of the like IBC plumbing is automated, and you can retain pretty strong privacy, because if you keep most of your assets on Namada, when you unshield just a little bit to do some shielded action, there's no linkability between the assets which you unshielded and the action which you took to the rest of your assets or your actions. So there's just like someone unshielded 5 Osmo and swapped it to Atoms and sent it back to Namada, right? But no one knows anything more than that interaction took place. Of course, the swap on osmosis is public, but any other linkability information is private if you use the Namada Shield pool. So we're interested in providing that kind of like basically a front-end and interface that makes it very easy for users to get most of the privacy that they want almost all of the time, and still do the things that they want on other Cosmos ecosystem and Ethereum ecosystem applications over IBC and the bridge.
And maybe that's like kind of an interesting and spicy question here, but you are not the first privacy approaching project, so to say. We also have, for example, Secret Network in the space. We have Penumbra. So to not dive too deep into the tech, because of course, completely different architecture. We are talking about blockchains that are using the Cosmos SDK here. But in terms of privacy, where would you make the most significant distinction between these privacy approaches?
Right. So maybe just to group things a bit, both Namada and Penumbra use zero-knowledge proof-based privacy architectures, while Secret uses TEEs, particularly, at least at the moment, the Intel SGX. Those have very different security guarantees, as in the TEE has been frequently exploited in various ways. There was one most recently, if you go to sgx.fail, I think you could read about the details, Andrew Miller and some other people, that would compromise your privacy if you use these systems, unfortunately. I mean, TEEs are a sort of cool concept, but because they rely on the secure hardware as opposed to math, it's very hard to make them secure in the same sort of way. Like the sort of assumptions that cryptographers make when they design zero-knowledge proof systems are very correspond to sort of abstract computers doing abstract things. So they reasoned about adversaries who are very, very powerful and designed their systems to be sort of mathematically sound about in that sense. Whereas SGX is designed to be kind of like, it's just hardware built by Intel, which is designed to be sort of hard to it's designed to make it difficult to read the inside of the chip from the outside, but it's not subject to the same kind of like cryptographic reasoning. So it's just much like it's not that Intel is doing a bad job or the secret network is doing a bad job. It's just harder to make this kind of system secure. And unfortunately, the ways in which the SGX has been broken in the past also, in some cases, would have allowed de-anonymization of past interactions. Users who used such a product could find that their transactions weren't private after all. Now, I hear that Secret has plans to perhaps update their technology stack over time, so that could change. That's just how things are at the moment. Namada and Penumbra both use zero-knowledge proof-based systems. I think they even both use systems based on kind of Zcash lineage. I don't know Penumbra as well, of course. I think they're mostly focused on different product propositions. So Penumbra is focused on their sort of batch swaps. So it's like a AMM DEX, which has some amount of also private transfers, and it has I guess batch privacy, as the batch size and amounts are revealed, but perhaps not the individual trades. Whereas Namada only does private transfers, and the difference there is just that we're like separating out. At least from our perspective, we're separating out the privacy from all of the applications. So we think users want to do lots of things, and we want them to do those on other chains, not on Namada. Namada is only trying to solve the problem of privacy, but it's trying to make interoperability as cheap as possible, which is why, for example, we've built this like custom Ethereum bridge. So I think they're targeting somewhat different propositions. And Namada and Penumbra can also interoperate. In particular, when we build this kind of shielded action system for swaps, I think we'll probably do a kind of automatic routing. So if users want to, swap assets that have good liquidity pairs on Penumbra, then their assets would be sent from Namada to Penumbra and back to complete the swap using shielded actions. So, more privacy, the better. But yeah, these systems are trying to solve slightly different problems.
You just mentioned that you want to make interoperability as inexpensive as possible. You also mentioned the custom Ethereum bridge. So let's talk about this. What's behind there? Why is it like more inexpensive compared to other bridging solutions? And I think what most people care about these days the most is it safe?
Right. So you might ask, why build an Ethereum bridge? I mean, there are already several actually pretty good Ethereum bridges in the Cosmos ecosystem. There's Axelar, there's Gravity. There's also some not so good ones, but I won't mention those. Why build a bridge? There's nothing wrong with those bridges, and Namada will also support interoperating with them, to be clear. We just want to give our users an option for bridging that is as inexpensive and requires as few additional security assumptions as possible. So when you use Gravity or when you use Axelar as a user, you are also, even if you're sending assets to Namada or to Osmosis or to some other chain, you are also including the sort of validator set of those bridges as a security assumption, and the code of those bridges as a security assumption. Like if the validator set is Byzantine, or there's not enough at stake to deter bribery attacks or something like this, then your assets might be at risk. Which is not to say that will actually happen. It's just, if you use a bridge and then another chain, you're adopting both of those chains into your security assumptions. So if we build a bridge into Namada and users want to use Namada from Ethereum, then they only have to adopt Namada. So it's just a strict reduction, which is why from that perspective, it's valuable. From the cost perspective, we think latency matters. And by building a bridge directly into Namada, we can make transfers from Ethereum to Namada free and very low latency, on the order of probably tens of seconds, something like this. And withdrawals are not quite free, but users pay fees only on the Namada side. And then we have kind of a bidirectional market, which batches withdrawals from Namada to Ethereum. So it's mostly just like it may seem like these distinctions are minor, and in a kind of theoretical sense they are, at least the latency distinction. But in a practical sense, it really matters whether things are fast. Like if we want to entreat users to use Namada for private transfers, the difference between like a 30-second or a 60-second transfer and a 5-second transfer is the difference between people using Namada or not. Like, I won't wait 60 seconds to try and do my payment. I just won't. It's not worth it. I'll go do something else, or I'll send it transparently. So we're just trying to get those latency numbers down as much as possible, and reduce security assumptions as much as possible. It makes Namada easier to explain, and it makes it easier to ensure that we have like the users have a correct understanding of the system, so that they can use it safely.
Yeah, and I mean, I really love this approach because it's like really like focused on the user friendliness, so that people like really that people really start using crypto like they would also use TradeFi, so to say, because also people don't want to use their credit cards in that way, that they have to wait so long or so. So I think this really follows the approach of setting up an infrastructure that allows like real mass adoption, and not mass adoption that crypto people can live with. So I really like that. But yeah, let's, speaking of infrastructure, I think we also got a question here from the chat, asking you to share the code in order to maybe launch a Namada node. So where are we in terms of developments here? So how can people, for example, validators can get involved? And I guess you will also launch a token at some point. So can you walk us through here as well?
Yes. So the Namada public testnets are live, and you can find the code at Anoma/Namada on GitHub. And you can find on docs.namada.net, you can find instructions on joining the testnet. It should be pretty straightforward, but if it's not, please holler.
Perfect. Yeah, definitely give it a shot. So yeah, let's talk a little bit about that. So are you like, do you have a timeline in regards of a mainnet launch? We
For
just
Namada?
touched based on the testnet. Yeah.
Q1.
Q1 already. Okay, that's pretty soon. And I believe this also comes like with a token launch. So could we also talk about the upcoming token a bit?
Mm-hmm. So yeah, Namada has a proof of stake token. We have not sort of sold this token. We're just giving it away to various parties, including existing contributors to, or past contributors to Anoma. We haven't finalized all of the distributions yet. We expect to do some combination of kind of airdrops, targeted retroactive public goods funding, allocations to individuals and organizations who've helped build parts of the Namada technology stack, which includes us, but it also includes people in the dependency graph. Like we depend on a lot of code from Tendermint. We depend on IBC. We depend on some research performed, especially by the Electric Coin Company on Zcash. We're trying to, it's hard to like the causal calculus is pretty complex, so we can't get everything perfect to like exact precision as to who contributed, but we're trying to cover the dependency graph as best as we can to a reasonable degree of accuracy. So expect a lot of retroactive public goods funding.
Nice. Yeah, sounds very cool. And when the mainnet is live, how many validators will you support?
Probably 150 or something to start. I mean, it's Tendermint, so same constraints.
Okay. So for validators who run mostly Cosmos infrastructure, Namada will be pretty straightforward, I guess.
Namada should be straightforward, yeah. It is different, so it's not the Cosmos SDK, so some tooling might need to be adopted to that, but the Tendermint is standard.
Okay, I see. And yeah, like last question also in regards of scalability, because we just touched based on the user friendliness. How high will the transaction throughput be? So how scalable will Namada be?
Luckily, Namada does simple things like process shielded transfers, and shielded transfers are cheap to verify, so it should not be hard to hit thousands to tens of thousands of transactions per second. There's like, while there is a lot of sort of demand for block space in some blockchains, a lot of this is MEV or trading or other things. Like, I'm much more concerned with actually getting users to use the system. I think we will have no trouble handling transaction throughput. You could handle the transaction throughput of Visa or MasterCard or something without much difficulty.
I see. And guys in the chat, please feel free to ask questions, because there's like one question I want to pass to you. I think you're the best person to answer this. Why can't we upgrade Tendermint with privacy for all chains?
Right, it's a good question. So Tendermint, the way Tendermint works when it works with applications is the Tendermint does the consensus part, and then the application does the state machine part. So the Cosmos SDK is a sort of SDK for building different applications, such as the Cosmos Hub or such Osmosis or Secret. I think those all use the Cosmos SDK. And those applications implement the actual transaction logic. So when we talk about privacy in blockchains, usually we're talking about private transactions. Private consensus is an interesting thing. I don't know of anyone actually building that. It is possible. That would be the thing that you would change Tendermint to do, is if you wanted like the consensus votes to be private, so you didn't know who voted, something like this. We also want to hold validators accountable. So there's some complex protocol design choices to be made there. But mostly when people talk about privacy, they're talking about application level privacy. So in addition to sort of noting that's the kind of distinction, so applications have to implement the privacy parts. Another good question is, why can't the Cosmos SDK or something like this implement privacy? And the answer is that it can. It just hasn't yet. I hope that happens, actually, and I would be thrilled if other parties in the ecosystem can make use of some of our research and implementation work, which is all open source. The more privacy in Cosmos, the better. I think a reason why it doesn't happen in practice is just that the cryptography is quite specialized and tricky to work with. Most of us are in Rust. Unfortunately, the sort of Cosmos ecosystem is still pretty Go bound. So it's not, requires a little bit of glue to integrate. But yeah, I'm hoping that other zones and other Cosmos projects could integrate some of our cryptography, perhaps some of Penumbra's cryptography, some of this stuff over time, and become generally more private.
I see. This was like very, also very, very good question. So guys, again, feel free to put them into the chat. But yeah, last question from my end. I think we touched based on a lot of interesting things. So how can people follow the project's process? How can they reach out to you if they are like running into problems when setting up a node, etc.? So yeah, could you give us like some good links, so to say?
Good question. You can follow Namada on Twitter at Namada Network, and you can also DM us with questions. And if you join the testnets, there's some chats we can invite you to, and you can find all the code on GitHub. And you can also find me. Yeah, I'm trying to leave Twitter actually, but at least still there for the moment. You could probably find. I'm not going to say my email because I get too much spam, but you could, if you look a little bit, you can find it. And always happy to receive questions or inquiries.
Yeah, guys, feel free to follow the handles that were just mentioned. And with that being said, Christopher, thank you so much for joining the show. I think we dive very deep into both projects, and I wish you a Merry Christmas in
Merry Christmas in Germany. Thank you. And happy holidays, everybody.